to take advantage of that and assign traffic to these different radio access technologies, and that becomes a cognitive radio resource management problem as well. A lot of the examples that I'm going to give are going to be in the context of dynamic spectrum access or flexible management of spectrum, because that has gotten the most attention from the cognitive radio and cognitive network community. So when we're talking about flexible spectrum management, that can be done in a coordinated or autonomous way. In a coordinated way, you think of some entity that's actually a referee in the use of spectrum. So you're using spectrum more flexibly than before, so you're not relying on those rigid allocation rules like the FCC chart that you saw yesterday in one of the early slides. But this flexible management of spectrum is still coordinated by someone. And that someone may be, for instance, a spectrum broker, some entity that brokers the exchange of spectrum among different users. Or that entity can be a virtual operator that actually buys spectrum on the run, according to the demand from various operators, and then aggregates that spectrum and provides the service to the end user. You can have things like spectrum sharing or pooling, where you can imagine multiple licensees having some spectrum that they contribute to some pool, and then they have access to that entire pool whenever they need it. You can think about virtual handovers, where you might have different networks coexisting, maybe big cells, small cells, and sharing spectrum in some way, and then users get handed over between the large cell and the smaller cell. Would be another way of doing coordinated flexible spectrum management.
So what would be in your case kind of this autonomy? Would it be more that is in for example in the radio or in the network?
So where does the autonomy lie? It depends. So you can imagine a secondary use of spectrum that is completely up to the individual radios, so more of an ad hoc network type of scenario for secondary usage. So there are lots of military applications that look at that. So in that case, all the autonomy is in the radios themselves. They need to figure out what the spectrum environment is, and then they need to coordinate among themselves. Or you can think about a secondary use of spectrum that's more infrastructure based, so something like 802.22, which is a standard designed, well, Andrea talked about it yesterday, but designed for regional area networks making secondary use of TV spectrum, in which case the idea is that it's largely centralized and coordinated, at least by the base station, where the base station may even, well, in the early concepts of 802.22, the base station would tell the radio to sense the spectrum and then report back, and it would aggregate all that information and then decide on what spectrum to use. Now things have evolved more into the use of geolocation databases, but regardless, it's more centralized, and the flexible spectrum management occurs, but it's coordinated by this base station. Okay? So it depends. In the research literature, you see both, but researchers like difficult problems, right? So kind of the more difficult, the better. And so you see a lot of work on extending this autonomy as a way to also exercise this question of what happens if you really give autonomy all the way to the radios. Is it possible? Is it complete chaos, or are there mechanisms that will lead to even a more efficient distribution of resources? And I'll give some examples of of these, and they can be in unlicensed bands, shared bands, where you start looking at the opportunistic access to, say, an ISM band, so a band that doesn't require a license. But maybe when you look at multiple possible channels within that band, and the opportunistic access and selection of these channels, so a more dynamic scenario than what we have right now with Wi-Fi, for instance. Or you can be talking about the license band. So either secondary access to license bands, which is starting to be envisioned at least in some of the auctions of licensed spectrum. So, a few years ago, there was a famous auction around the 700 megahertz spectrum in the U.S. The U.S. turned off its analog digital TV several years ago, 2008, I want to say. And then they auctioned off some of this spectrum that is part of the digital dividend, but those auctions come with the caveat that secondary use of the spectrum should be tolerated within some guidelines. Or you can think about things like the coexistence between femtocells and macrocells within the spectrum that's owned by a single operator, for instance. Okay, so a couple of examples of this. The first one I have already mentioned before, which is this idea of a spectrum broker that controls access to part of the spectrum, so that you could have, for instance, an operator that has some of its own spectrum that's leased to it, but then there are some peaks in demand that whenever it cannot meet the demand with the existing spectrum, it could go to the spectrum broker and obtain an additional lease, time-limited lease, for a certain region, for a certain part of the spectrum, to augment its own spectrum holdings. And this region that the broker controls may actually have base stations of several providers. It may be an area of high demand, so several providers have their own infrastructure there, and the brokers assigns this additional spectrum on demand and sells, of course, the spectrum. Yes?
This is what Spectrum Bridge is doing in the US.
I don't know if their model is exactly like this, because I don't know what their connection with the operators is right now. I don't know if you know about Spectrum Bridge.
Yes.
Is it?
They are the database operator themselves, and they simply directly give the connection to the user.
Okay, and are they operating mostly in TV spectrum?
Only in TV spectrum.
All in TV spectrum, okay. But this idea could be broader, where you have one of these spectrum brokers even controlling part of the licensed spectrum itself. So the operators might kind of give out part of that for that spectrum that they may have idle to the spectrum broker for it to control. Okay, a second example would be a more autonomous example, which would be, for instance, the control of a topology in an ad hoc network, where each of the nodes is trying to set its own transmission power and the operation channel to achieve some overall network connectivity objective. So there is some work that's funded by DARPA, by the Department of Defense in the US, under a program called Wireless Network After Next, WNAN, that does exactly that. So they're interested in forming ad hoc networks, and they funded the development of these radios, so they're proprietary military radios, with some of these characteristics of spectrum agility and so on, for deployment in battlefield situations. And the radios need to find each other, and then they need to establish connection with one another and form this ad hoc network in a hostile environment. So it's DARPA actually funded some of the early development in cognitive radio in a program called XG, and then that program was followed up by a program called WNAN, both of which have generated actual implementations that are starting to be used by the military, by the army. Okay. Another example of autonomous, non-cooperative, flexible use of spectrum would be the secondary usage of spectrum by detecting a white space and then fitting a signal into that particular white space. So there's this idea of spectrum shaping, or sometimes called spectrum sculpting, where you basically find out how much of a white space you have, of an available band you have, and then you shape your signal to fit into that, and still respecting the block edge mask of the primary user so that you don't generate undue interference. A lot of the work, of course, is also assuming the use of some sort of multi-carrier modulation, so FDM is often assumed, and then you can play around with the number of carriers that you use, you can do carrier aggregation, you can do all of these things to actually make your signal fit into some spectrum of variable size. And you could also have some sorts of autonomous but cooperative sharing of spectrum. So you might have multiple secondary users that are opportunistically using the spectrum, but they also need to cooperate among themselves to negotiate how to best make use of that available part of the spectrum. There may be economic incentives for them to negotiate the use of the spectrum. It may just be agreements of, okay, based on fairness, now it's your turn, now it's my turn, that sort of thing. They may exchange information about the incumbent or the primary user, how likely it is to appear, and so on. So there's some work on this idea of secondary users cooperating in the opportunistic use of spectrum, which, by the way, is often forgotten in the literature. So a lot of, especially the early work, is very much about the secondary user and the primary user, and how does the secondary user, use that spectrum when the primary is not present. But the reality is that there might be multiple secondary users that also need to worry not just about the primary, but about the other secondaries. Okay. So what approaches are used for to solve these problems?